Hello, welcome to this video. We are going to review the functionality of the reflective circuit with an infrared emitting LED and a black infrared receiving LED, both 5 millimeters in size. The module has 3 pins, VCC for power, GND for ground, and OUT or DO for digital output. The LDR changes its resistance according to the reflected infrared signal it receives, and the LM393 compares this signal to a threshold set by a potentiometer. Depending on the light intensity, the digital output on the OUT pin changes state, which can be used to turn devices like an LED on or off. By adjusting the potentiometer, you can set the light threshold that activates or deactivates the digital output, enabling applications such as automatic control of the wheels of a line-following robot. This circuit is calibrated for a distance that we will measure soon. Its output is a 0 to 5 volt DC digital signal, on or off, but it's important to understand that it is vulnerable to intense nearby lights. It has a hole for M3 screws for mounting and features a slim and versatile design. Its status LED only indicates the output. As you can see, it is sensitive to a different but very close light source. We are going to adjust the potentiometer so that we can find the exact point where this sensor can be properly triggered with the current light level. Turn the potentiometer until it stays permanently off, then slowly adjust the potentiometer until it turns on by a reflection stimulus from your hand. This way, the sensor will have the highest range at that light level. With this sensor, we were able to measure, using a reflective surface, up to 6 centimeters of range or a little over 2 inches. Thanks for watching. Please comment if there's something specific you'd like to learn. Remember to subscribe, activate the bell, and give us a like. See you next time.